Musculoskeletal and Skeletal Systems, 3.4 to 3.6. 3.4. The musculoskeletal system. The musculoskeletal system, figure 3.15, is made of bones, muscles, joints, cartilage, tendons, and ligaments. It helps us stand upright, move, maintain posture, and protect delicate organs, all under the control of the nervous system. Muscles pull on bones via tendons. When a muscle contracts, the tendon transmits force to the bone, causing movement at a joint. The adult human skeleton is about 12 to 15% of body weight. Explanation. The musculoskeletal system, figure 3.15, is the body's movement machine, made of bones, muscles, joints, cartilage, tendons, and ligaments, all controlled by the nervous system. Muscles pull on bones through tendons. When a muscle contracts, the tendon passes the force to the bone, creating movement at a joint. Bones make up about 12 to 15% of body weight. Activity 3.4. Bone and muscle mass. Estimate the weight of your bones and muscles. 1. Record your total body weight on a scale. 2. Find average bone and muscle mass percentages for your age, gender, and body type. Adult males, approximately 40 to 50% muscle. Adult females, approximately 30 to 40% muscle. Bone, approximately 12 to 15% for all adults. 3. Multiply body weight by these percentages. 4. Deflate and compare with total body weight. 5. Compare with classmates and find the class average. Discuss why bone or muscle mass differs between individuals. Explanation. Activity 3.4 turns the numbers into a real calculation. Weigh yourself, then use average percentages. Muscle, approximately 40 to 50% in adult males, approximately 30 to 40% in adult females. Bone, approximately 12 to 15% for all adults, to estimate your own bone and muscle weight and compare with classmates. It shows how much of body weight comes from muscle and bone and why it varies between people. (3.4.1) In action. Activity 3.5. Table 3.5. Move different body parts and record the movement each can make. Complete rotation, partial rotation, bending, turning or side raising, or up-down for elbow, shoulder, knee, neck, fingers, toes, wrist. Some parts move in many directions, others in one, because of the types of joints. A joint is a junction between two or more bones. Joints allow movement but cannot move bones by themselves. Explanation. In Activity 3.5, you test how the elbow, shoulder, knee, neck, fingers, toes, and wrist move, rotate, bend, turn, etc. Some move freely in many directions, others only one way. The reason is the type of joint. A joint is a junction between two or more bones. Joints allow movement, but cannot move the bones by themselves. Muscles do that. (3.5) Types of joints. Ball and socket, hinge. Ball and socket joint, shoulder, figure 3.16. Rounded top of the upper arm bone fits a shallow hollow of the shoulder bone. Forward, backward, sideways, and circular movement. With the collarbone, it forms the shoulder girdle. Hinge joint, elbow, knee. Bends and straightens in one direction like a door hinge. The kneecap protects the knee. Explanation. A ball and socket joint, shoulder, figure 3.16, has the rounded head of the arm bone sitting in a hollow of the shoulder bone, allowing forward, backward, sideways, and circular movement. With the collarbone, it forms the shoulder girdle. A hinge joint, elbow, knee, only bends and straightens in one direction, like a door hinge. The kneecap protects the knee. 3.5. Types of joints: pivot and fixed. Climax: head pivot joint, skull backbone. Lets the head turn side to side, shaking no, like a doorknob in its socket. Fixed joints, skull bones. Flat bones in their world. It make 3.6, like each mother's, and cock. Emotional joints, fixed and fixed. Protect the brain, eyes, and ears, even when the body moves. Explanation: a pivot joint connects the skull to the backbone, letting your head turn side to side, shaking no, like a doorknob in its socket. A fixed joint joins the flat skull bones so they cannot move at all. This keeps the brain, eyes, and ears safe, even while the body moves. 3.6. Skeletal system. The skeletal system is a framework of bones giving strength and protecting internal organs. It includes the skull, vertebral column, and rib cage. The backbone, vertebral column/spine, is made of small bones called vertebrae, with a cartilage disc between each for cushioning and flexibility. The rib cage, 12 pairs of ribs, attached to spine and to the sternum by flexible cartilage, protects the heart and lungs and expands/contracts during breathing. Explanation: the skeletal system is the bony framework that gives strength and protects organs, including the skull, vertebral column, and rib cage. The backbone, spine, is a chain of small bones called vertebrae with a cartilage disc between each for cushioning and bending. The rib cage, 12 pairs of ribs, joined to the spine and sternum by flexible cartilage, protects the heart and lungs and expands and contracts while breathing. Portion 62. Enrichment boxes. To go beyond, cork cambium. As plants age, cells below the stem epidermis start dividing as lateral meristematic cells, forming the cork cambium, which makes dead, compact, waterproof cork cells. This forms the bark. Meet the scientists. Sipra Guha Mukherjee with S.C. Maheshwari achieved a breakthrough in plant tissue culture, growing a complete plant through anther culture on an artificial medium, greatly aiding crop improvement. Bridging science and society. Yoga. Yoga, postures, breathing, meditation, improves flexibility, posture, and breathing, reduces stress, and prevents lifestyle diseases. 21st of June is International Yoga Day. Good posture, nutrition, exercise, and yoga keep bones, muscles, and joints healthy. Explanation: these extra notes go a little further. Cork cambium. As a plant ages, cells below the epidermis start dividing and make dead, waterproof cork cells that form the bark. Scientists. Sipra Guha Mukherjee and S.C. Maheshwari grew a full plant from anther culture, boosting tissue culture and crop improvement. Yoga. Improves flexibility, posture, and breathing, and reduces stress. International Yoga Day is 21st of June. Think as a scientist. Totipotency. In 1958, F.C. Stewart showed that single cells from carrot phloem can regenerate whole plants. Phloem cells first dedifferentiate, regain the ability to divide, into an unspecialized mass, then, with nutrients and growth chemicals, redifferentiate into roots, shoot, and a full plant. This ability is totipotency, and such cells are totipotent cells, similar to a zygote forming an entire organism. Table 3.6 to discuss. Solid medium plus nutrients, light, no air, weight reduced. Liquid medium plus nutrients, light plus air, 20% increase. Liquid medium plus nutrients, no light, air, Reduced. Best growth needs liquid medium, nutrients, light, and air. Explanation. In 1958, F.C. Stewart grew whole carrot plants from single phloem cells. The cells first dedifferentiate, go back to being simple dividing cells, then, with nutrients and growth chemicals, redifferentiate into roots, shoot, and a full plant. This power of a single cell to build the whole organism is totipotency. Such cells are totipotent, like a zygote does. Table 3.6 shows best growth needs liquid medium, nutrients, light, and air. Bridging science and society. Crown gall disease. Crown gall disease causes tumor-like swellings on stems due to rapid, uncontrolled cell division caused by the bacterium Agrobacterium tumefaciens. Scientists studied how it transfers genetic material into plant cells. Today, Agrobacterium is used in tissue culture and genetic engineering to introduce useful genes for valuable phytochemicals, improved crops, and disease resistance. Explanation. Crown gall disease makes tumor-like swellings on stems from rapid, uncontrolled cell division caused by the bacterium Agrobacterium tumefaciens. By studying how this bacterium inserts its genes into plant cells, scientists turned it into a tool for genetic engineering, now used to add helpful genes for better crops, disease resistance, and valuable phytochemicals.
The cell is the basic unit of life. In multicellular organisms, similar cells work together to form tissues. Different tissues combine to build organs, each designed to perform a specific function, and all systems together create a complete living organism.